question is asking us, what is the major product of the following E2 reaction? You might not necessarily be given the mechanism of the reaction. So you might just be asked, what is the major product of the following reaction? That would make the problem a little bit more difficult because you'd have to figure out the mechanism on your own. But here, let's kind of take a look at our reaction and think, why is this an E2? Our substrate, the alkyl halide, is secondary, and our reagent is a strong base only. The reason why I classify it as a strong base only is because it's very sterically hindered. So steric hindrance usually makes nucleophiles very weak. So you have a strong base only and a secondary substrate, both of which will help favor an E2 reaction. So in order to answer this question, we have to kind of think through the possible product. So I'm going to go ahead and do that. So again, here's our alpha carbon showing us that we have a secondary substrate. We know this is a strong base because of the steric hindrance and the negative charge on the oxygen. Don't worry about the sodium, that's just our counter ion. It doesn't participate in the reaction. So in order to kind of think about what's going to go on here, we also have to consider the beta carbons. So we have 2 beta carbons in this case. And also very importantly, we have to think about the beta hydrogen atoms. So there are 3 beta hydrogen atoms on this molecule. And that's important because in order for an E2 reaction to occur, you have to have elimination of the beta hydrogen along with the leaving group. So thinking about the possible products can kind of help us think about that. The only hydrogen atoms that will be eliminated are the beta hydrogens. If you go out to like gamma positions, those hydrogens can't be eliminated in an E2 reaction. So let's think about the possible products that we can form from these beta hydrogen atoms. So I'm going to label this 1, 2, and 3. So 1 will give us a product that looks like so, with the double bond right here. We can't really tell for sure whether H1 gives us the E or the Z product. I'm just going to kind of arbitrarily say H1 will give us one stereoisomer and H2 will give us the other stereoisomer. Okay, so if we think about H2 and the product that can be formed from it, actually let me draw it down like so. We would end up with this molecule. And then H3 is tricky. It's tricky because it's a lone beta hydrogen atom. So in order to predict a product for H3, you have to think about the fact that only anti-periplanar hydrogen atoms will be eliminated. So the hydrogen atom and the bromine, this guy and this guy, have to be anti to each other. Right now, they are not anti, they're on the same face. I know that because they're both wedged. So because they're both wedged, we know that we have to rotate around the alpha beta bond in order to get them to be anti to each other. So if I'm going to think about the possible product from H3, I'm going to rotate that bond around. And that's going to give us this isopropyl group pointing down. And we are going to form our double bond right here between the original alpha and the original beta. So this product is going to be the product that is the only product that's possible to form. So because there's only one beta H, we can only form one stereoisomer. So the product where their 2 biggest groups are opposite is not possible. Right? So now that we know the products that we can form, let's think about this, our answer choice system. Okay, so answer choice 1 is on the board. Okay, so this is answer choice 1 right here. This is answer choice 2. And this is answer choice 4. So 3 is not possible, again, because it won't have the correct stereochemistry, the anti-periplanar arrangement of leaving group and hydrogen, beta hydrogen. And then we can cross off 4 because 4 would eliminate from a gamma position. So it's too far away from the leaving group to actually eliminate out there. So our 3 options are 1, 2, and 4. So how do we know which is the major product? So the major product in an E2 elimination is going to depend on the base that you're using. So the fact that we have a strong base here and the fact that it's bulky is very important for predicting the major product in this case. So the bulkier the base, the more likely you are to form the less substituted Hoffman product over the Zaitsev product. So let's take a look at our examples. 4 is tri-substituted, 2 is di-substituted. So what that tells us is that 4 would be termed technically the Zaitsev, and 1 and 2 are our Hoffman products. And so we can cross off 4 from consideration, because 4 would only be formed if we had a small, strong base, like say we had Na8, for example, or a reagent that could be a small, strong nucleophile / base, like sodium hydroxide, would also favor the production of 4. So we don't form 4 because of the fact that our reagent here is very big and bulky. So big and bulky favors the Hoffman, the less substituted alkene product. So how do we choose between 1 and 2? Here, stereochem becomes important. So it is more stable to have your largest groups opposite of each other. So in this case, we have a methyl and then this big R group. And over here, we have the methyl and the big R group on the same face. So it's going to be more stable overall for the 2 largest groups to be on the same face. So we can cross 2 off and we can say that answer choice 1 is the correct answer here, because with the big bulky base, we favor the Hoffman product. And according to steric hindrance, the E product is going to be the more stable product. So it'll be the major product in that case. Molecule 2 and 4 are both minor products. So I'll write that in, major, minor. And